Hello, it's Mrs. Wallace. How are you? I just wanted to finish some of the notes so that you could begin to work on some utility theory problems. This is a topic that really relates to our understanding of the demand curve. And when we think of consumers, of course, are always making decisions about the quantity that they demand based on given prices. So the law of demand is very connected to that. If the price goes down, say from $8 to $4, we know that the quantity demanded might increase, let's say from 10 to 20 or something like that. So that very behavior is something we're interested in. How and in what way do consumers make those decisions? And we're going to suggest that there's a few things that matter when you make purchasing decisions. And, eventually we'll look at behavioral economics, which kind of give us even more reasons why perhaps we make decisions that we do, or even our, heuristics and shortcuts and things like that. There's a lot of influences on, why we make the decisions that we do, even decisions that may ultimately not be good for us. But economists, who are very mathematical, like to use models, they suggest a few things. Let's assume that we're rational. Assume basically, and being rational means, we are consumers who want to, one thing, maximize our utility. If we didn't want to do that, we wouldn't be rational. So, it doesn't make any sense when people buy things that aren't good for them, because ultimately, we're rational. Economists would also say we know our preferences. We all know that often that's not the case, but let's pretend that we know our preferences. Budget constraints. Economists assume that resources are scarce, and in this case, it's going to be dollars. We have a budget constraint. I know I have a budget constraint. I'm sure you have had that experience. Prices matter. So, of course, just like we're studying in the law of demand or the law of supply, prices matter a great deal. We are going to be using one example of a utility function or utility theory. There's a lot of them. There's a variety of different ways that economists make sense of this. How come we purchase a certain quantity of gum or bananas or yogurts or whatever it might be? Everything that you purchase, you kind of come out with a certain number. At a certain point, you stop purchasing it. Why is that the case, right? So certainly we can make a relationship where what is it that the consumer is doing if you have multiple products that you're looking for, say in Target, right? So we'll call this product A and product B. Let's say product A is notebooks and product B is markers, and you're going to Target and you have decided your utility is maximized when you come out and consume notebooks and markers, and you're trying to decide, how much of everything. One thing you want to know is how much do you actually like something? We can actually quantify your marginal utility of the last one that you put in your cart. So say that you had 5 notebooks in your cart, you just put the 6th one in and you had 100 utils, okay? That's like the 100 utils. Maybe when you put the last box of markers in your bag, and maybe it's the 8th one or whatever it is, maybe it was 50 utils. So already we can kind of see, wow, I really like, my notebooks a lot more than I like my markers, right? My preferences are pretty clear. My marginal utility is higher for that last one of the notebooks, higher than the last one of the box of markers I put in my cart. But the price also matters. So rather than just comparing marginal utility, where do I have the higher marginal utility? Because then I would be like, I'm just going to buy notebooks because that's easy, right? I like notebooks better. But what if I go and notebooks are like $10 a piece, right? My marginal utility for every dollar that I spend is now pretty high, right? It's going to be 10. Okay, my marginal utility per dollar is 10. My marginal utility per dollar for markers could be, let's say this is the price of a box of markers on sale and it's $2, right? Now my marginal utility per dollar of markers is 25, okay? These are, first of all, not equal. So the last notebook that I put in my cart gave me a marginal utility per dollar of 10. The last markers that I put in my box gave me a marginal utility per dollar of 25. I should definitely buy more markers because I get literally a lot more bang for my buck with the markers. I get more utils for every dollar that I'm spending, and the more that I spend on markers, my marginal utility is going to diminish. That is the law of diminishing marginal utility. So when I buy the, let's say 7th box of markers, the 8th box of markers, the 9th box of markers, and so on, my marginal utility is going to actually decrease, okay? And that is going to then help me make these fractions equal. I will keep consuming more and more and more markers up until the point where my marginal utility of notebooks and my marginal utility of markers for the last one I put in my cart are exactly equal, okay? Let's kind of imagine that we're looking at a problem. We can say, assume apples cost $1. So I'm just gonna write that up there. Apples cost $1. Oranges cost $2, okay? So far, so good. And we have quantity, the first apple, the second apple, the third apple, and I also have total utility for both apples and for oranges. So I know if I eat 3 apples, my total utility is 45. If I eat 3 oranges, my total utility is 65. But I also know in this problem that apples are $1, oranges are $2, and the customer has $7, okay? If the customer has $7, that's me, and I'm looking to shop, okay, what do I buy first? What is the combination that maximizes my utility? Because I might not just want to buy apples or just oranges. What's the quantity that's going to maximize my utility? And of course, I can only spend $7. The way to think about this is to actually figure out your marginal utility per dollar, okay? So because I was given total utility, from this, I can figure out my marginal utility, okay? So forget marginal utility per dollar, because that's what I have to do. My marginal utility per dollar of apples has to be the same as my marginal utility per dollar of oranges. But let's assume first, I just want to make a column that says marginal utility, okay? So I'm just going to draw a little marginal utility here. This, I'm just going to put a whatever, because the total utility is 0 and the quantity 0. When I go to have the very first apple, my total utility is 20, so my marginal utility for that unit is 20. When I go to have the second apple, now my total utility has jumped up to 35. That makes my marginal utility 15, because it's the difference between the total utility at the first apple. When I ate the second apple, I got 15 utils as additional utility for a total of 35. When I had the third apple, I ended up with 10 marginal utility. The fourth apple, I end up with 5, okay? And I can already see diminishing marginal utility after the second apple, after the first apple rather. My marginal utility is diminishing. And then when I get to the fifth apple, okay, here, my marginal utility is, let's see, 2. Okay, so I have diminishing marginal utility. Now, because this is $1, I really don't have to put this in marginal utility per dollar, because it's going to be the same numbers. It's going to be 20, 15, 10, 5, and 2. If this was anything but $1, I would have to divide my marginal utility, this is my marginal utility, divide it by whatever the price is, $5, $2, whatever. And that's what we're going to have to do for oranges. So first of all, with oranges, I need a column for marginal utility. Okay, so let's do that. This I can just put a little line. I don't really have marginal utility for 0 units. For the first unit, my marginal utility is 30. It's equal to my total utility for the first unit, because I've only consumed 1. When I consume the second, my marginal utility is going to be 20. It's the difference between 30 and 50. When I consume the third one, okay, I have a diminishing marginal utility. It's still positive, still adding to my total utility, but it's diminishing. And then when I get to the fourth unit, I have a difference of 10. And when I get to the fifth unit, I have a difference of 5. My marginal utility is 5. And in this case, the good is not $1, it's $2. So I have to divide all of these marginal utilities by $2. So here I'm going to actually have my marginal utility per dollar is 15. My marginal utility per dollar is 10, 7.5, and 5, and 2.5, okay? So this is what I can compare, my marginal utility per dollar for oranges. I can compare that to my marginal utility per dollar for apples, okay? And if I were to look at this and say, well, okay, I'm gonna go shopping and I'm gonna spend $7, what do I buy first? Well, I'm gonna start with the quantity, the first one. If I have to buy one thing, an orange or an apple, what am I gonna put in my cart? The first orange gives me a total utility per dollar of 15. The first apple gives me a total utility per dollar of 20, okay? I'm gonna buy the one that's higher. So I buy an apple. And then I go, okay, what's next? The first orange is a marginal utility of 15. The second apple is also a marginal utility of 15, marginal utility per dollar of 15. I'm gonna buy them both, okay, because I'm indifferent and it doesn't matter which one I buy first. So I'll buy a second apple and I'll also buy my first orange, okay? And now I have spent $2 on oranges and $2 on apples. I can continue to purchase. When I go to the next one, so the second orange, I have a marginal utility per dollar of 10. I'll buy that, okay, for $2 more. So now I've spent $6. And when I do a one more apple, I'll notice a few things. I am now, marginal utility per dollar is also 10. So I have quantified this now. My best combination is to buy 2 oranges, okay, which cost me a total of $4, and 3 apples, which cost me a total of $3. I did not buy the third orange because I had already spent my $7. If I was going to buy a next good and I had more money, I would buy my third orange over the fourth apple because my marginal utility per dollar is 7.5. You'll also note when I bought the last of the oranges, my marginal utility per dollar, I put the second orange in my cart, marginal utility per dollar was 10 because my marginal utility was 20 and the price was $2, okay? My marginal utility for apples, okay, for the third apple was also 10, okay? So these two numbers are equal, right? 10 equals 10. Because my margin utility was 10 and the price was $1, okay? So I know that I am maximizing my utility if I walk out the door with 2 oranges and 3 apples, okay? I can actually plot this. Your demand curve, I'll come to that in a second. Let's do this second one together and then we'll come to the plotting of the demand curve. This is another example. One thing to pay attention to is the information that you are given, okay? So I just wanted to do the second problem. It looks identical. Apples, $1, oranges, $2. So what is this crazy stuff? Same exact thing. It's a little bit different because what I have here, I like to just draw a line down the middle so I know this is one product, this is another product. I have the first, the second, the third, the fourth, and so on. In this case, first of all, the data are a little different. Second, we're looking at marginal utility. If I'm given marginal utility, I do not need to find marginal utility. If I'm given total utility, I need to find marginal utility. I could also be asked to add up the marginal utility for the first, second, and third, say, goods, okay? So I could find out what is the total utility. If I have 3 apples, I got 10 marginal utility from the first one, 8 from the second, and 7 from the third, right? So my total utility would be 25, okay? And that's something I can figure out because I should really be using this one, not marginal utility per dollar. It's just that because the price is $1, the numbers are the same, but I really should figure out total utility, not based on marginal utility per dollar, but marginal utility, okay? Because that's what we're interested in. But in this case, when I want to do like the shopping like I did before, I don't have to put it into total utility. I've already got the information I need. And in this case, I know I have a little bit different of a budget. I have $10, okay? What's the optimal combination? And again, you could do this with like 6 different products. You would just have more data to work through, but it's the same kind of thought process. The first thing that you buy is the thing with the highest margin utility per dollar. Buy it, okay? And you can calculate your spending. $2, I spent $2. Then I buy the one that is next, right? And I'm indifferent. Doesn't really matter whether I buy the first apple or the second orange. I'm indifferent to them. They both give me a marginal utility per dollar. And so far, I've spent $5, $4 on oranges, $1 on apples. Then I'll buy, 9 is greater than 8, so I'll buy my third orange. And then that has now put me up to $7. I still have a couple more dollars, so I'll buy one more orange because this number's 8. This number's 8. I'm indifferent between the two, and I actually can afford to buy them both, so I'll buy the extra orange for a total of 4 oranges, okay? And I'll buy the second apple for a total of 2 apples. So the combination where I'm maximizing my utility is if I purchase 2 apples and 4 oranges. That's a 4. Doesn't look like a 4, but that's a 4. 4 oranges. Okay, so 1, 2, 3, 4 oranges for a total of $8. 2 apples for a total of $2. Total of $10. With any problem like this, you have to make sure, first of all, you've spent all your money. You're not maximizing your utility if you spend $5 and $5 isn't going to apples and oranges. We're rational, so we're assuming that we are, if we desire apples and oranges, that is what we truly desire, and that's the decision we'll make, so we're not going to not spend our money. And then the second thing is we're also going to assume that if we are maximizing our utility, the marginal utility per dollar will be equal. So this 8 and this 8 are equal. The second apple and the fourth orange, when we put them in our cart, they give us the same marginal utility for that last dollar, okay? And that's what the formula is basically saying. Marginal utility of apples is over the price of apples should be equal to the marginal utility of oranges over the price of oranges. And the last, back to my data, and I say, okay, pretend that this isn't $2 anymore, it's $1. So instead of using this data, I'm gonna use this data. So now I'm comparing this column and this column. So what am I gonna buy? Well, I'm gonna buy the first, the second, the third, the fourth, the fifth. I'm gonna buy 5 oranges before I even buy the next apple. 5 oranges, the first apple, the second apple, and the third apple. I'll buy the fourth apple and the 6th orange, and I will have spent my $10, $1 on every good. So when the price actually lowered to $1, we actually see the combination of goods, the number of oranges that were demanded is different, okay? So we get a quantity demanded that is going to be greater. And I can come back. So, you know, when you have, and this is just kind of where we can actually derive the demand curve. And you can use your imagination here. We're working with set data. That could be for one consumer, or it could be for a group of consumers. Just like a demand curve could be for one person. So this could be like Januka's demand curve, or it could be like the whole class's demand curve, right? Or everybody in New Jersey's demand curve. So sometimes we have like aggregate groups. In this case, we just kind of can plot our points, right? When the price was $2, we know that the person might have been demanding 4 oranges, right? That's what happened. If we actually lower the price, so now I go data and say, okay, when I lowered it to $1, instead of 4 oranges, I wanted 6, okay? And that's how I got my demand curve. With the deriving of a demand curve, you want to be able to change the price and figure out what the quantity demanded might be in relation to some other good, okay? So we're making this decision in relation to other goods we might also have utility for, and again, you could do like 6 goods at the same time or 10 goods at the same time. And as crazy as this whole thing sounds, like, you know, it sounds like we don't really do this when we go to Target. Nobody sits there and like, how many euros am I getting from, you know, purchasing this candy bar? Nobody does that, but at the same time, you do think about what is it I want more, and you might think about also the price and how much that matters, okay? So consider this as like an introduction to consumer theory. I will get more into it as we move along in the course. We will spend some time with behavioral economics, but this is kind of a neat way to look at utility, okay? Be well. I'll see you in class on Thursday. Don't forget you have a quiz, and we'll work on some utility problems, okay? Be well.